Welcome to the Crazy Hat Chemist. So another video in thermochemistry. Bam! So today we're doing a thermochemistry calculation number 1. So let me read you the question. It says, how much heat is required to raise the temperature of a 6.2 gram sample of aluminum from 25.0 to 35.0 degrees Celsius? A relatively simple problem. You need to know what the equation is that you're going to use. Remember the qualifying exam for the medical college test here, okay? So what is that? It's called the Q equals MCAT. So that's what that is right here. So Q is equal to MCP times delta T. And delta T is the final temperature minus the initial temperature. The question is, what are you solving for in this problem? Which variable? Okay, it says how much heat. And what is the heat term? The heat term is the Q. So that's what you were doing. You were solving for the Q. So the rest of these numbers come directly from that question. So first of all, what are the numbers that fit into that equation? Here it is. Okay, that is 6.2 grams. That goes in for the M, which is the mass. Okay, then I have the final temperature. Remember, the final temperature is the last temperature. It starts out at a temperature and then it ends at a temperature. That final temperature is the ending temperature. That's the 37.0 degrees Celsius. Then, what's the beginning temperature? What's the initial temperature? And that's at 25 degrees Celsius. Now, the next thing is, what's the specific heat capacity? You need to watch one of my previous videos on units of energy of this same unit of thermochemistry. And when I talked about specific heat capacities, the CP is the specific heat capacity. That is the amount of heat required to raise 1 gram of any substance, in this case aluminum, by 1 degree Celsius. Okay, so you need to re-watch that video and then you can find the specific heat capacity for aluminum. Or you can look up in the Handbook of Chemistry and Physics and find it in there, or you might be able to look it up in your textbook in the table of contents or within the chapter of thermochemistry. Okay, but we're going to find out what that value is here, and we're going to plug that right into here, and we're going to solve for Q. So here I have put in all the numbers. That is the 6.2 grams, that is the mass, the specific heat capacity for aluminum, that's 0.897 joules per gram degrees Celsius. And then the temperature, that is the final temperature, 37.0 minus the 25.0. Okay, remember the specific heat capacity for aluminum, that's coming directly from a constant. That is a constant for aluminum, that's coming from a textbook. That's coming from one of my previous videos. You should see that before you do these problems mathematically in your calculator and just blindly look at everything, you're going to make sure that your units cancel out. If your units don't cancel out, you will not get the correct answer and you're wasting your time. So, before you plug this into your calculator, make sure your units cancel out. My grams are going to cancel out. My degrees Celsius are going to cancel out. And I'm going to be left with joules. Joules is a heat term. And what am I solving for? Heat. So that makes sense. Okay, so now I'm going to do the mathematical operations that are necessary. And that is numerator times numerator times numerator divided by denominator. Okay, now I do have a subtraction problem here within the parentheses, and since that's in the parentheses, I'm going to do that subtraction problem first, then do the multiplication, and then the other multiplication. I'm going to round to the fewest number of significant figures because my last operation is eventually going to be multiplication. Okay, I need to have units on my number as well. Always have to have units. Okay, so here we go after we get it correct, and that's Q is equal to 67 joules. So what does this mean? This means it requires 67 joules of energy to heat 6.2 grams of aluminum from 25 degrees Celsius all the way up to 37 degrees Celsius. Hopefully that worked out well for you mathematically. Check your work. Make sure your units cancel. It's critical that your units cancel. And make sure you have units and it's rounded correctly in your final answer. This has 2 significant figures. I am the Crazy Hat Chemist, and I got a great hat here for you. I got this from one of my students, as I get many of my hats from students or former students. Okay, I think they went to a nice beautiful place where they have alpacas. Okay, if you like that video, give me a thumbs up, subscribe to my YouTube channel. I'm going to see you next time for another thermochemistry problem mathematically. Bye for now.